How many of you guys wear contacts? If you wear contacts, you probably use saline solution. Now, saline solution is predominantly sodium chloride, and this example that we're going to look at is actually asking us to determine how to make a saline solution with a concentration of 0.5 molar. So if we look at this, it asks us how much solid sodium chloride is required to make 450 milliliters of 0.5 molar solution. So we have a lot of information in this problem, and first what I want to do is I want to kind of break it down just so we know what is relevant. And so this asks how much solid sodium chloride. When you see how much, that's asking you for mass. So we're going to be solving for grams. Now we are solving for grams, and it tells us that we want to make 450 milliliters of 0.5 molar solution. So we have some pieces of given information that are going to help us solve this. Now again, just like when we talked about calculating concentration, there are a couple different ways that we can go about solving this. I'm going to show you both ways. Whichever way works best for you, please feel free to use that. So the first way is using the molarity formula, calculating moles, and then going to grams. So if we look at this, I use the molarity, which is 0.500 molar. We are solving for moles, and we know our volume, which is liters. Now the problem gave us milliliters, but hopefully in your head now you can convert between milliliters and liters in your head, move it 3 decimal places. So 450 milliliters turns into 0.45 liters. So from this molarity equation, we know molarity, we know volume, we can find moles. When we find moles, it's 0.225 moles of NaCl. The problem doesn't want moles, it wants grams. So what I can do is I can take my number of moles that were calculated, I can use the molar mass from the periodic table, and I get 13.1 approximately grams of sodium chloride. However, this problem gives us one of our values that has 2 significant figures. This 450 only has 2 significant figures. This 0 at the end is not significant because there's no decimal. That means that our answer has to be rounded to 2 significant figures. So instead of 13.1, we're going to round our answer to 13 grams of NaCl. So again, to summarize this first method, I used the molarity formula to find moles. Then I used my number of moles and molar mass to find grams. Now in the second method, what I did is I did this all in one step using dimensional analysis. I started with the given piece of information of volume. Now as you go through dimensional analysis problems, molarity is a conversion factor. Never start with molarity. Okay, molarity is a way for you to convert from from moles to liters. Okay, it's always a conversion factor from moles to liters. So I'm going to start with my given volume, 450 milliliters. I'm going to go from milliliters to liters. Okay, remember 1,000 milliliters in 1 liter. That cancels out my milliliters. Now, I'm at liters. I can convert from liters to moles using molarity. So I go for every 1 liter, remember your for every is always 1 liter. For every 1 liter we have 0.5 moles. And then for every 1 mole we have 58.44 grams. We're using molar mass. So as we went through here, we converted our volume to liters, used molarity to go to moles, and then used molar mass to get to grams. Notice this is the exact same thing we did in the first method. It's just all in one step.